Alright, so we're going to continue solving problems related to probability, and these are from the topic called the addition law. So things, basically events that are mutually exclusive, meaning that they have no intersection. And formally, the events, if you take the intersection of any two events, you should get that the intersection is an empty set. Alright, so one way to express this is that the probability of the union, right? The probability of union of I equal to 1 up until n of AI is equal to sigma, that means the summation of I is equal to 1 to n p AI, given AI intersect AJ is equal to an empty set for I not equal to j. All right, so basically what this means is that if you have the probability of A1 union A2 union A3 all the way up until AN, or it could be an infinite number of events, this is equal to probability of A1 plus probability of A2 all the way up until probability of AN, and given that any two events, so as long as this I subscript and this j subscript are not equal to the empty set for I not equal to j. So if you have A1 and A2, then it's an empty set. If you have A2 and A3, it's an empty set. All right, so basically that's what I'm saying. This holds true. This is the addition law given in your textbook. This is the addition law. And we know the inclusion-exclusion principle for two events says that if you want probability of A union B, and in this case they are not mutually exclusive, this is probability of A plus probability of B minus the probability of A intersect B. All right. And we have discussed these two. So these two formulae are the only ones we're going to be using to solve the questions for this topic at least. And in the next topic, we're going to discuss independent events. All right. So let's go back. 40 girls were asked to name. So let's just draw. So part A asks us to draw a Venn diagram. And to do so, we'll draw our sample space first. So our sample space, or the world, it basically represents all the possible outcomes. All right. So 40 girls, we have total 40. So all the numbers we draw, they have to add up to 40. We're asked to name the capital of Nepal in India. 19 knew the capital of Nepal, 20 knew the capital of India, and 7 knew both. All right. So let me draw this as two circles for my two Venn diagrams. My first circle, I'm going to call it N. My second circle, I'm going to call it I. So N is the number of girls who knew the capital of Nepal, and I basically is the set of girls who knew the capital of Nepal, and I is the set of girls who knew the capital of India. And we are given that 7 of them knew both, right? 7 knew both. All right. 19 knew the capital of Nepal. So 7 plus 12, right? In total, when we say 19 knew the capital of Nepal, we include the people who only knew the capital of Nepal plus the people who knew the capital of Nepal and India. So these two together have to add up to 19, right? So we have 12 people who only knew the capital of Nepal, 7 who knew the capital of Nepal and India both, and together we have 19 people who knew the capital of Nepal. So how do I get 12? 19 minus 7 gives me 12. All right, 20 knew the capital of India. So I have 7 here. This number has to be 13, right? All right. So 13 plus 7, total 20 people knew the capital of India. But remember, we have 40 girls. So we have how many students here? We have 20 here plus 12 is 32 students. So basically, that means that 8 girls did not know the capital of India or Nepal. All right. So now we are done with the Venn diagram. Find the probability that a randomly selected girl, so we are selecting one girl, knew the capital of Nepal but not of India. So how many people know the capital of Nepal but not India? Well, 12. 12 out of 40, which is 6 out of 20, which is 3 out of 10, which is 30%, so 0.3, right? And that is part one, just one of these capitals. So you don't want to know both, you only want to know one. So 12 or 13, right? You either only know the capital of Nepal. So these are mutually exclusive, remember? Only knowing one, you either only know for Nepal or you only know for India. You don't know both. So you can add those two probabilities together. So the probability that you know the capital of only Nepal is 12 over 40, plus the probability that you know the capital of only India is 13 over 50. So 40. So how many students satisfy? Well, 25 over 40 students. And that is, I think, 5, 5 eighths of 40, so 5 over 8. All right, so 3 over 10 and 5 over 8. These are our two solutions. And we are done with question 7. All right. So it says, in a survey on pet ownership, 36% of the participants own a cat, 20% own a dog, but not a cat, and 8% own a cat and a dog. So what percentage? So if you get a question like this, it's easier if you draw a Venn diagram again. All right, so we have a Venn diagram. We draw our circles. So this is our sample space. All right. So it says 20% own a dog, but not a cat. So let's say this first circle is cat, the second circle is dog. You can draw them in another. You can draw the dog circle first as well. It doesn't matter. So 20% own a dog, but not a cat. So I'm going to put the 20% here, because they don't own a cat, but they own dogs. All right. 8% own a dog and a cat. So 8% own both, a dog and a cat. And it says 36% of the participants own a cat. All right. So what percentage of people only own cats, right? If 8%, we have 36% own cats and 8% own dogs as well, then that means that 28% of participants own only cats, right? So together, when you add them, you see that when you add them together, you see that 36% of the participants own cats. All right. And now we want the percentages to add up to 100, right? So we have 56% who own neither a cat nor a dog. All right. And now that we have this, what percentage of the participants owns neither a cat nor a dog? So how do you get 56%? So the solution is So the solution is 56%, right? How do you get 56%? Well, 28 plus 8 plus 20 gives me 56. Sorry. Yeah, gives me 56%, right? So if I add these three percentages together, I get 56. But now I know that the total should be 100%. So when I add the percentage of people, so the solution is not 56. When I add the percentage of people who have neither a cat nor a dog, I should get 100%. So I need to do 100% minus 56%. That gives me 44%. And I get 44 here. Why? If you do 28 plus 8 plus 20 plus 44, you get 100%. So 44% of the people own neither a cat nor a dog. All right, so sorry about that. So your solution is 44%, not 56. You have to subtract 56 from 100. All right. So your solution is 44%. Okay. Question 9. So you have a Venn diagram of 3 sets now. Repaired 132 vehicles last month. So your denominator is going to be 132. The number of vehicles that required electrical, mechanical, and bodywork repairs are given in the Venn diagram. All right. Find the probability that a randomly selected vehicle required mechanical or bodywork repairs. All right. So now we have two events, right? So how do we find mechanical or bodywork repairs? Again, we have to use inclusion or exclusion because we have intersections here. So probability of mechanical or bodywork, right? Union represents R. So this U, which is the union symbol, represents R. You can also write OR. It's going to be PM plus PB minus PM intersection B. So how many vehicles required mechanical work? Let's see. That is going to be the total number of cars in this circle, right? So I'm going to have to do 13 plus 47 plus 5 plus 18. All right. So I have 13 plus 47 plus 5 plus 18. 13 plus 47 plus 5 plus 18. All right. So that is 83 cars out of 132 vehicles required mechanical work. Let's do the same for body work. We have 5 plus 18 plus 26 plus 11. 5 plus 18 plus 26 plus 11. So we have 60 cars in total that required body work. But we need to subtract away the cars that required both mechanical and body work. And these are the cars in this intersection here, 5 and 18. So you add 5 plus 18, and that gives you 23 over 132. All right. So if you do the addition, 83 plus 60 minus 23 gives you 120 over 132. And as a simplified fraction, this is going to be 10 over 11. So that is your solution for question, I believe, 9. All right. 10 over 11. No bodywork repairs. Right? So how do we get the probability that the car had no bodywork repairs? Well, there are two ways. Probability of no bodywork. I can either add the numbers here, right, which is outside of the bodywork. So that is one solution, right? Is going to be how many cars did not require, so are not a part of this B circle. Well, 12, 13, and 47. So I can add them directly. And my denominator is out of a total of 132 cars. 12 plus 13 plus 47. And basically it's 72 divided by 132. And this adds up to 6 over 11. So that is your solution. And it says exactly 2 types of repair. All right. So how many cars went through exactly 2 types of repair? Well, 11 cars went through electrical and body. So basically it can be any 2, right? We don't have any specification. So basically we need to find probability of exactly 2 types, right? So this can be probability that it went to body and electrical, or the probability that, and because these are we are not considering the probability that a car went through all 3. So these events are going to be mutually exclusive. We're going to consider them as mutually exclusive events. We don't want to count the cars that went through all 3. So it can be body and electrical, it can be body and mechanical, or it can be mechanical and electrical. So now let's look at the intersections. Body and electrical, we have 11 cars. Body and mechanical, we have 18 cars. And finally, mechanical and electrical, we have 13 cars. So we have 11 plus 18 plus 13. We have 42 divided by 132, and that simplifies as a fraction. That simplifies to 7 over 22. All right, and we are done. At 9. Question 10. The 100 learners at a technical college must study at least once. Okay, basically, we are given a Venn diagram. And it's sort of a different type of Venn diagram than probably what you're used to. But all right, so we have students who must study at least one subject from pure mathematics, statistics, and mechanics. All right, the numbers studying these subjects are given in the diagram. Who does the number 17 refer to? All right, so we need to look at the number 17 carefully. Number 17 is inside this circle, inside the circle of P, is inside this circle of S, but is not inside this circle. It's not inside M, right? So the number 17 refers to students who study P, which is pure mathematics, pure math, and who study S, so statistics. So that is it. And you can specify, but they don't study mechanics. So you have to be specific because there are students who are here as well. There are 32 students who study all three, and these students would also be students who study pure math and statistics. So you need to specify that they don't study mechanics. All right, so that is part A. Find the probability that a randomly selected learner studies pure math or mechanics. All right, so the probability of pure math or mechanics, or I can write union mechanics, again, because they have an intersection, they are not mutually exclusive. So that is probability of pure math plus probability of mechanics minus the probability of pure math intersect mechanics. So let's find the total number of students. To do so, we can just add these numbers up. Or can we? All right. So we can add the numbers up. So 33 students who study only pure math, 17 students who study pure math and statistics but not mechanics. We have 32 students who study all three subjects. We have 7 students who study statistics and mechanics but not pure math. And we have 11 students who study statistics only. All right, so we have 100 students in total. And how many of these students study pure math? Let's see. They are going to be here. So 33. So we have a total of 100 students. So my denominator is going to be 100. And 33 plus 17 plus 32, that is 82 students study pure math. And how many students study mechanics? Well, 32 plus 7. 7 study mechanics. So 39 students study mechanics. And how many students study both? All right. So the intersection of pure math and mechanics is here. 32 students study, let's see. You can't take this number because they include the students who study statistics as well. So we need to figure out how many students study pure math and mechanics. But it looks like all the students who study pure math and statistics, pure math and mechanics also study statistics. So you just need to subtract 32 over 100. All right, so 82 plus 39 minus 32. That gives you 89. So your solution is 89 over 100. All right, so that is the solution to BI. Exactly 2 of these subjects. All right. So you need to select, so this is 1, right? So exactly 2. So there are 17 students who study pure math and statistics but not mechanics. That is exactly 2, right? There are 7 students who study statistics and mechanics but not pure math. And let's see if we can find any more combinations. So 33, so you don't need to consider this. You don't need to consider 11. There are 7 students who study both statistics and mechanics. There are 32 students who study all 3, so you can't count them. And you have 17 students. So these are the only 2 cases. So you have 24 over 100. All right, and you can simplify this further. You can write this as 12 over 50, which becomes 6 over 25. All right. So that is the solution to part 2. And list the 3 subjects in ascending order of popularity. All right. So let's see. How many students take pure math? 33 plus 17 plus 32 students are taking pure math, right? So you have 82 students in the pure math class. You have 32 plus 7, we have 39 students in the mechanics class, and you have 17 plus 32 plus 7 plus 11 students, 67 students in the statistics class. So pure math is the most popular, followed by statistics, followed by mechanics. So it says in ascending order. So mechanics, and then statistics, and then pure math. So ascending means increasing order of popularity. All right, we are done with question 10. So I hope I can erase this. All right. Events x and y are such that probability of x is this, probability of y this is, probability of x and y is this. State giving a reason whether events x and y are mutually exclusive. No, because probability of x and y does not equal to 0. All right. Using a Venn diagram or otherwise, find p, x, or y, right? Probability of x union y is probability of x plus probability of y minus probability of x intersect y. So we don't need to draw a Venn diagram. You can directly take the values from here. 0.5 plus 0.6 minus 0.2, right? And you get 0.9. All right. Find the probability that x or y, but not both, occurs. All right. So now let's draw sort of a small Venn diagram, maybe here. So probability of x and y occurs 0.2%, 20% of the time, right? And x occurs 50% of the time, or 0.5. So 0.3 needs to be here, right? So that when you add them together, you get 0.5, and you need 0.4 here. So when you add them together, you get the probability of y occurring to be 0.6. All right. And if you add them together, right, if you add all of these together, you should get 0.9. And basically, you need 0.1 in your sample space, right? So that altogether, probabilities need to add to 1. Either x happens, or y happens, or x and y happens, or x or y happens, or none of these happens. So none of the events happening has the probability of 0.1. Right, so find the probability that x or y, but not both, occurs. So you need to pick the values from here, 0.3 plus 0.4, but not the middle one. And that is just 0.7. So 70% of chance that x or y happens, but not both. All right, we are done with 11. A, B, and C are events. Okay, we are given these. State which pair of A, B, and C is mutually exclusive. This intersection is 0. So that means that A and C are mutually exclusive. So whichever has intersection 0, or the probability of the intersection being 0, that is going to be mutually exclusive. All right. Using a Venn diagram or otherwise, find PA union B union C complement. All right. So how do you solve this? Well, if you remember, we know that probability of any event S is equal to probability of is equal to 1 minus the probability of S complement, right? And this is a formula that we discussed at the beginning. So basically, the probability of A union B union C complement is 1 minus the probability of A union B union C complement. And basically, taking the complement twice just means that they negate each other. So you only have A union B union C, right? Complement is just the initial event, A union B union. All right, so we have discussed that the way that we are going to calculate this is by doing 1 minus probability of A union B union C. Now we need to figure this out. And to do so, let us draw. I'm going to show you two ways. First of all, I'm going to show you the formula. So now if you remember, the probability of A union B was the probability of A plus the probability of B minus the probability of A intersect B. But if you have three events, probability of A union B union C, then this becomes probability of this is probability of A plus probability of B minus probability of A intersect B. If you have three events, this becomes probability of A plus probability of B plus probability of C minus probability of A intersect B minus probability of A intersect C minus probability of B intersect C, and then plus probability of A intersect B intersect C. So if you use this formula, we can directly substitute our values in. Probability of A is 0.3 plus probability of B is 0.4 plus probability of C is 0.3 minus probability of A intersect B is 0.12, probability of A intersect is 0 because they are mutually exclusive, probability of B intersect C is 0.1, and finally probability of all three happening, because A and C don't intersect, all three cannot happen. So this is going to be 0. And if you add everything here together, 0.3 plus 0.4 plus 0.3 minus 0.12 minus 0 minus 0.1 plus 0, you get 0.78. So your answer is going to be 1 minus 0.78, which is 0.22. So that is how you use the formula. So this is the formula, and it's probably going to be useful if you remember this. However, another way to do this would be to draw the Venn diagram. All right, so let's draw the Venn diagram. So let's say we have A, we have B, and A and B intersect, but A and C don't intersect. So only B and C intersect. So my Venn diagram looks something like this. All right, so the probability of A intersect B is 0.12. I'm going to put the intersections first, and I'm going to work my way out. Probability of B intersect C is 0.1. All right, so probability of C only is 0.3, so I'm going to put 0.2 here, so that when I add them together, I get 0.3. And similarly, probability of A is going to be 0.3 minus minus the intersection, right? So the probability of only A happening is 0.18. And why? Because I need to be able to add these two together to get 0.3. And what is the probability of B? Well, probability of only B happening is you add these two together, and then you need to subtract it from PB, from 0.4. So 0.4 minus 0.22. So if you add these two together, you get 0.22, right? And then probability of B has to be 0.4. So if you do 0.4 minus 0.22, you get 0.18. Why? Because if you add this, and this together, that forms B, and B has to be 0.4. All right. So if you add from this, you can get A union B, right? So A union B 0.18 plus 0.12 plus 0.18 plus 0.1 plus 0.2. So you just add together the different regions. And if you do so, if you do the final calculation, you get 0.22. So you get 0.78, so you get 0.22 again. So however way you find easier, you're free to choose it. All right, so let's continue on with question 13. So the diagram opposite, which means this one, shows a 30 centimeter by 30 centimeter board with two rectangular, let me lock this first. All right, two rectangular cards attached. The 15 by 20, so basically we just want to look at the diagram. A dart is randomly thrown at the board so that it sticks within its perimeter. So basically, this whole thing is the board. All right. And use the areas. Okay. So basically, the total is going to be the total area, right? So 30 times 30 is going to be 900. And we don't really care about the units because they're going to cancel out anyways. So use the areas to calculate the probability that the dart pierces both cards. And the probability is going to be, we're going to have to find this area. How do we do so? Well, let's think about it. We have 12 by 8 here. So 12 times 8 is going to be 96. So the area of this blue section is 96 centimeter squared. And it says that the 15 by 20 centimeter card covers 1/4. So that means I need to do 96 divided by 4. And this area is 24. Alright. And now, because it covers half and half here, right? This length is going to be 4. And this length is half the length of 12, is going to be 6. 6 and 4 gives me 24, right? Because this area is 24. Alright, so the probability that it pierces both cards is the area of this section, 24, divided by 900. Alright. So the probability that it pierces at least one of the cards. So one way to do it is to use inclusion-exclusion, right? So you can do the area of the blue card is 96 by 96 by 900, right? That is how much the blue card occupies. The red card occupies 15 by 20, right? So 15 times 20 is 300 over 900. But remember, we counted this part twice. We counted it once here and once here. So we need to subtract it. So 24 by 900. And basically, if you simplify this, you get 12 over 300. So the first solution in simplified fraction is 1 over 25. All right. So this gives you 31 over 75. If you simplify this expression, you get 31 over 75. So that is the correct answer. So if you simplify 24 over 900, right? 24 over 900, you're going to get 2 over 75. Sorry, so I simplified it wrong. So 24 over 900 simplifies to 2 over 75 and at least one of the cards. So this is, if you add these together and you simplify, you get 31 over 75. So you can use your calculator to directly get. So it says exactly one of the cards. So that means it's either this part or it's this part. It cannot be this part. This part is excluded. So we just want to add the two areas together. So we got... So we know that, hey, if this is 1/4, then this has to be 3/4, right? This is 1/4, so this is 3/4. So I just need to do 3 over 4 of 96. That was the total area I calculated. So 0.75 times 96. 3 over 4 of 96 is 72 over 900 plus this area. And this area is just the total area. So 15 times 20, right? I do 15 times 20 and minus 24. So 276. So that gives you 72 plus 276. So that is 348 divided by 900. And that simplifies to 29 over 75. All right. So we are done with question 13. And let's do question 14. So again, for these types of questions where you're not sure of the set, it's always helpful to draw it out. So I'm going to draw my Venn diagram. All right, something like this. A, B, and the whole world is S. So I know PA, PB, and PA union B. Remember your formulae. PA union B is PA plus PB minus PA intersect B. So I can calculate PA intersect B here. It's just going to be PA plus PB minus PA union B. Alright, so what is PA? PA is 0.4 plus PB is 0.7 minus PA union B is 0.8. So that is going to give me 0.3. So this middle section is going to be 0.3. Because PA is 0.4, this has to be 0.1. Because PB is 0.7, this has to be 0.4. And 0.4 plus 0.3 plus 0.1 is 0.8. So the outside has to be 0.2, right? All right. So if you add all of these numbers together, you should get 1. Or another way to think about it is the whole area or the whole thing should be 1. So A union B is this part, right? This part is A union B. So 1 minus 0.8 here gives you 0.2. So it's going to be outside. All right. So now we need to find P, A union not B. All right. So let's look at not B first. Not B is this part. Not B is this part. It's everything outside of B, right? And you want not B, and A union means that you sort of add A to this not B part. So A, most of it is already covered. What part of A do you need to add more? Well, you need to add this 0.3. So basically, you can already see the answer. It's going to be the everything minus 0.4. That's one way to do it, right? So it's going to be everything, 1 minus 0.4 to get directly 0.6. That also works. Or you can just add everything else, 0.1, 0.3, and 0.2. So that gives you 0.6 as well. All right, so 0.6. And how do you find not A intersect B? So P not A intersect B. So A complement, right? So what is not A? Not A is everything outside of the circle of A. And what does it have in common with B? Well, you will see that it only has this area in common with B, right? It's going to be exactly this area. Intersect means you want to find the common area, right? So this area was common with B. So that means that the answer is 0.4. All right, we are done. And the last question, this one, I'll probably solve it in the next video, and I'll title the video Miscellaneous Problems. And I'll also solve 2 questions from the previous topic that I skipped, from geometric sequences and series. So do check it out if you want answers to some of the questions there. All right.